All right, let's take a look at Lesson 5 from Unit 5 of Algebra 1. In your student workbook, it's on page 317, and this is Illustrative Mathematics by Imagine Learning. We're looking at question 1. A population P of migrating butterflies satisfies this equation, where W is the number of weeks since they began their migration. And we're supposed to complete the table with this population. So we notice that the beginning population of the butterflies is 100,000 at time 0 at the beginning. And then from there, we're supposed to use a factor of 4/5 in order to complete this table. So when you're deciding how to type this into your calculator, you can do times the fraction button or times 4 divided by 5. That's what the fraction's doing. And then there's also the times 0.8 option in decimal form. So whichever works for you. And if we do times 4 divided by 5 times 4 divided by 5, and you fill in the rest of these things, after you get these values, you're then going to go graph it. But we need to start at 100,000. So it looks like we're going to be counting by 10,000s on this table. And so on and so forth, okay? Along the bottom here, we're just going by 0, 1, 2, just counting by ones. And then we also need to label and scale the sides. So label would be W, and over here's the population P, wherever you want to put that. So fill in the table, get the dots. You should have some sort of a decreasing function where it starts up high and goes down low with the dots, right? It should be a curving down type of a function. Think carefully about how to choose the scale. We did so. Okay, what is the vertical intercept of the graph? And what does this tell you about the butterfly population? The vertical intercept of that graph is 0, 100,000, and that means that the starting population of butterflies was 100,000. About when does the butterfly population reach 50,000? And so after you graph this, you're going to look at your graph and say, is there an exact point where it hits 50,000, or is there an in between? So you could say between this many weeks. So whichever your graph shows, you can answer question D as well. This graph shows chemical in a water sample, and it's decreasing exponentially. So we need to go ahead and get this factor. What is it decreasing by? Using the two given numbers. And so 800 divided by 1,000, do that on your calculator, is the same as 8/10, which is the same as 4/5, which is the same as 0.8. So either way, using your factor is 8/10, 4/5, or 0.8. That's what we see that this is going down by, and they've asked for point A, B, and C. So they want us to continue this table from 0, 1,000, 1, 800. They want us to go by 0.8, 0.8, 0.8. And so multiply this by 0.8, multiply again by 0.8, and multiply again by 0.8. And that is going to give you the coordinates of A, B, and C. And I did go ahead and put them over here on the graph after I got them with my students. The graph shows the amount of chemical in the water at different times that it was first measured. Select all the statements that were true. So number A, B, or letter answer choices A, B, and C. The amount in the chemical water is decreasing exponentially. The amount is not decreasing exponentially, or it is not possible to tell. We're choosing between those, though it is tempting to look at this and say, hey, I can tell. It's starting at 0, 2,000. It goes down to 1,000, and then it goes down to 500. Even though it looks like it's decreasing by a factor of 1/2, we can't be sure. So if there's no numbers given and that's not on corners, we really cannot tell. So this one, though tempting to say part A was the answer, part C is actually the answer because it is not possible to tell for certain. Be careful with that. Part D, when it was measured, there were 2,000. Yep, that's the other one that is true. And these are no. After 4 hours, there were 100 milligrams. After 4 hours, there were 100. That also looks tempting, but we can't know for sure. So we do not choose part E. The graph shows the amount of chemical in a patient's body at different times. Could this be decaying exponentially? To know if something is decaying exponentially, we have to show that there is a common factor between the different coordinate points. And so we're going to use those outputs as we've been doing the whole time to divide. We need to see if 600 divided by 1,000 is the same as 360 divided by 600. So grab your calculator, do 600 divided by 1,000, do 360 divided by 600. And we did get a common factor of 0.6 for both. So we would say, yes, it is decaying exponentially because it has the same factor of 0.6, so we know it is. The height of a plant is 7, so I'm looking at all the answer choices that begin with 7. So it could be A, B, D, or E. And then we're going to select all the expressions that represent the height after 4 weeks if it's doubling each week. So in order to double, it needs to be a times 2, not an add. And times 2 repeatedly for 4 weeks. Yes, it's also that one, but not times 2 times 4. No. So B and D. Number of people who have read a new book at the beginning of January is 300. Number of people who have read the book doubles each month. So we do that times 2, times 2, times 2, times 2. And you can probably do these ones in your head without a calculator. Then they want us to notice, what do we see with the difference and what do we see with the factor? We notice that the factor for doubling is times 2. And what do we notice about the difference? Well, this is one of the characteristics of doubling. The difference comes out to the same thing that we are subtracting. So 600 minus 300 is 300. 1,200 minus 600 is 600. 2,400 minus 1,200 is 1,200. What happens when you're doubling is the difference is equal to what you are subtracting. The difference is equal to the previous term. The difference is equal to the previous term. If n people have read the book 1 month, how many will have read the following month? This is your equation or your expression for all n. So if we began with 300, it's doubling each month n times. Now for this one right here, I did do it in class with my students just because we haven't seen this since last semester, but we're looking for a way of using the elimination method to solve this system of equations. Remember that there's always 2 ways to do this. I can eliminate the x's or eliminate the y's. So for part A, while doing it in class, students said, okay, let's eliminate the x's by multiplying the top row by 3. Yes, that is a valid method, but what some students noticed that's a little bit easier is, why can't we just eliminate the y's? Those already have opposites. So if I cross out the y's, I get x minus 3x is negative 2x, and then 2 plus 5 is 7. And then I just solve that little tiny equation, and I get that x is negative 3.5. Now that I've solved for x, I need to go back into either equation and solve for y. So I'll just choose the top one, x plus y equals 2. Oops. 3.5 is what we got for the answer. Okay, so I just plugged in x is negative 3.5. Let's add that to both sides to solve for y. Once I get both my x and y answer, I then put those two answers together as a coordinate pair. So I'm going to write my answer as negative 3.5, comma, 5.5 as my xy coordinate pair for part A. If you had solved it the other way, yes, it would still work out and you would still get the same answer. Hope that worked for you. Next one, there are no automatic opposites, but notice that if I multiply the top by 2, I then could cross out the 4 and negative 4. So we're going to make a new row. Half of 2 is going to leave me 1x. 2 times 2 gives me 4y, and 2 times negative 13 is negative 26. And then the bottom row was already fine as is, just copy it down. 1x plus 1x makes 2x. Bye y's, those get eliminated. And negative 26 plus 8, use a calculator if that one confused you, is negative 18. We divide by 2 and get that x is negative 9. That's half my answer. I now plug back into either equation. I'll just pick this one. So y is negative 17 fourths, and yes, it's okay to put that into decimal form. So I put my final answer together, negative 9, comma, negative 17 fourths in an xy coordinate pair. And we're done.